Welcome to Chapter 3, Homework Questions 99 through 104. Question 99. Determine which similarity conjectures could be used to establish that the following pairs of triangles are similar. List as many as you can. Alright, so on part A, it looks like we have all the side links, so it appears that side similarity would be our first choice here. Just to verify, this would be 3. I'm going to go from the triangle left to the right. So 3, the smallest side on the next triangle is 3.6. Should be equal to 4. That's the middle length. So that would be 4.8 is equal to 5 over 6. So if those ratios are the same, then we can say side similarity. And when you simplify all those, we get a decimal of 0.8, and then the 3 is repeating. So they are all the same, so therefore we could go with side similarity. Now this first triangle, 3, 4, 5, you might recognize it as a potential right triangle. And the reason we know that is because 3 squared plus 4 squared is equal to 5 squared. That is a true statement, so it is a right triangle. So if we also verify that this is a right triangle by taking 3.6 squared plus 4.8 squared is equal to 6 squared, and that is a true statement as well, then you know that those are right angles. And then if we know they're right angles, then we also technically could use side angle side, because we know the sides are in proportion, we know the angles are congruent. So that one might not be as obvious, but definitely a possibility. On part B, we have 80 degrees, 80 degrees, 30 degrees, and 30 degrees. So we know that 2 of the angles are congruent, so we know that angle similarity could work. We also maybe potentially could use side angle side. We'd have to check the ratios. So we'll go 2 over 4 is equal to 3.5 over 7. And those both reduce to 1/2. So we also could use side angle side similarity. On part C, we have 1 side length and 1 angle. And even though those two are exactly the same, there's not enough information. We only have 1 angle, so we don't know anything about the other 2. And the side lengths both being 4 doesn't mean that the triangle's congruent. There's lots of possibilities in terms of what we could do with that. So this one, there's not enough information. And that does it for question 99. Question 100. You're going to have the owner of the pet store randomly pick a fish for your aquarium at home. A tank at the pet store contains 9 spotted guppies, 14 red barbs, 10 red tetras, and 7 golden pleiades. What is the probability, expressed as a percent, of getting a red-colored fish from this tank? So first off, how many total fish do we have in the tank? That's our possible outcome. So 9, 14, 10, and 7. So add those 4 numbers up. And so that looks like that'll be 40. And then how many do we have that are red-colored? So 9 spotted guppies, those are spotted. We have 14 red barbs, 10 red tetras, and 7 golden. So it looks like we have a total of 24 out of 40. And if we want, as it does say in the directions, to represent as a percent, so when you divide those two, you get 0.6, which represents 60% of a possibility of getting red. Part B, in a different tank that contains only golden pleiades, the probability of getting a female fish is 30%. If there are 18 female fish in the tank, how many total fish are in the tank? So there are definitely different ways to look at this. I'll kind of just show you one way. The probability of getting the fish is 30%. So if we know what the probability is, that's 30%, or if you want to do it as a fraction, that's fine too. So 30 out of 100, that's the... And then it says if there are 18 female fish in the tank. So the 30% represents the 18 out of the total, which we don't know. All right, that's what we don't know, how many total fish are in there. So this is one way to do it. We can cross multiply. We can multiply by 100x. We can change the 30 over 100 to 30%. or 0.3. Once again, lots of different ways we could look at this. I'm just going to go ahead and multiply by both sides by 100x, which if you cross multiply, it does the same thing. So let's see, we would have 100 times, 100 times 18, so that's 1800. And then the other one would be 30x. And then you can divide both sides by 30, and x would be equal to 60. So how many total fish do we have in the tank? We have 60 total fish. And if you're not sure about that answer, you can always go back and see that 30% of 60 is 18 as well. Question 101, multiply the expressions in part A and B, solve the equations in C and D. So on part A and B, you'll notice that they are not equations, so we're not solving anything, we're just multiplying. On A, we can use the distributive property or the generic rectangle. I'll do one of each. So on the first one, I'll use the distributive property. By using the generic rectangle, we found out that if you take 3x times 4x, that gives us 12x squared. That's typically that top left box. And then 3x times negative 5 is negative 15x. And then the other side length that you need to distribute is the 2. So then that's 2 times 4x is 8x. And then 2 times negative 5 is negative 10. Now remember, if you don't like using the distributive property and you always want to use the generic rectangle, then just use the generic rectangle. It doesn't matter which method you want to use. So the answer is 12x squared minus 7x minus 10. On part B, I will show you the generic rectangle just so you can see both methods here. This one does have 4x minus 1. It is being squared, so that means we actually, in our generic rectangle, it actually represents a true square since the side lengths are the same. And then we'll just find the individual areas of each of the 4 boxes. And then we can combine the like terms. So 16x squared minus 8x plus 1. Now on part C, it wants us to actually go ahead and solve. So we will go ahead and solve, and you notice the difference is C and D have an equal sign. So we're going to distribute the 2x, that's 2x squared plus 6x. And then we'll also distribute on the second one here, we'll get 2x squared minus 5x. And then distribute the 1, that's plus 2x minus 5. So we'll combine our like terms. On the right side, that gives us 2x squared minus 3x minus 5. You'll notice when we subtract the 2x squared from both sides, we get our nice zeros on both sides, so that works out really well that those are both gone, and now we're just left with a linear equation. And then we can get the variable terms on the same side, so I'm going to add 3x to get 9x equals negative 5, divide by 9, and x is equal to negative 5/9. Alright, and then on to D. So D, we have 3 squared, which is 9, plus x plus 1 squared. I'm not going to show my work on this one, but the answer for that would be x squared plus 2x plus 1 is equal to x plus 2 quantity squared. Once again, I won't show my work, but you can use the generic rectangle or the distributive property. That's x squared plus 4x plus 4. So go ahead and combine your like terms. X squared plus 2x plus 10 is equal to x squared plus 4x plus 4. Once again, when we subtract x squared to both sides, we get our zeros. And that's 2x plus 10 is equal to 4x plus 4. I'm going to subtract 2x to both sides. That leaves us with 10 equals 2x plus 4. Subtract 4 to both sides. 2x equals 6, divide by 2, and x is equal to 3. And remember, to check C and D, you could plug those back into the original equations and check to see that they actually do work. A and B, you're just simplifying the expressions. Question 102. A laser light is pointed at a mirror as shown below. If angle X measures 48 degrees, what are the measures of angle Y and angle Z? Justify your reasoning. So we know that angle X measures 48, so I'm going to go ahead and mark that in there so I can see what I'm looking at here. Thinking back to our angle measures, we have this line and this line intersecting. which means angle X and angle Y should be the same. So we know that angle Y, or the measure of angle Y, is equal to 48 degrees. And we know this because of vertical angles are congruent. Alright, and since vertical angles are congruent, their measures are the same as well. And then on Z, we know Z also is the same as Y because that is a reflection. Alright, and so if Y is 48, then Z would also be 48 degrees. So we know that the measure of angle Z is equal to 48 degrees because of the reflection of angle Y. So just make sure that you are justifying your reasonings on these and really all the problems that you're showing and explaining what they, how the answer is what it is. Question 103 on graph paper, graph the line LD if L has the point -2, 1 and D has the point 4, -4. So let's just go ahead and start there. -2, 1 would be right here, that's L. And D would be 4, -4. And it does want you to go ahead and graph that line. So we've graphed the line, now we want to find the slope of the line LD. So to find the slope, we can do our slope triangles. You can also use the 2 points and set up your slope formula, change of y over the change of x. You can use a table to do that. I'm just going to go ahead and use the slope triangle, and from point L to point D, and I guess maybe I'll go the other way. I'll go from D to L, so I'll go up 1, 2, 3, 4, 5 units, and then I'll go over, looks to be 6, and that is going to the left, so that is a negative. So based on that, the slope of the line would be change of y is 5 over change of x is 6, and I'll just put the negative in front. So -5, 6. On part B, we want to find LD, which means we want to find the distance. Well, you'll notice when you do your slope triangle, you created a right angle, a right triangle. Therefore, we can use Pythagorean theorem, and we say 5 squared plus, and since it's a distance, we don't really need the negative. I'll include it in there, but also show you that when you square a negative, you still get a positive anyway. So either way it works. 5 squared plus -6 squared is equal to that distance of LD, and that would be squared. So this would be 25 plus 36, and if you add those together, you get 61. And then to find that distance, we're going to take the square root so that we can get LD, and we'll get, that's not a perfect square, so you can either, it's the square root of 61, that would be the exact. So I'll do it this way. I'll say LD is equal to the square root of 61. That's the exact answer, or the approximate answer is 7.81 units. And pay attention to the notation right here. LD does not have a line or anything above it because we're talking about a measure. So continue to work on the notation as we go through. C, describe how you might determine the lengths of the sides of the slope triangle without using graph paper. And so that's kind of what I was talking about before on part C. Without using graph paper, if we didn't have it, then we could do, some of you might set up a table, do the change of y over the change of x. Some of you might just use the formula where we do delta y over delta x. So a couple different options though. One of them being this, where we do 1 minus -4 over -2 minus 4, and that will give us positive 5 over -6. The other option potentially is to set up a table and do -2, 1, 4, -4, and really you're doing the same thing but just in a different way. So the change here is you're going down 5, and the change here you're going up 6. So therefore your slope is delta y over delta x. So once again, different possibilities there. Question 104. On graph paper, which I forgot to put on here, sketch a rectangle with lengths 15 and 9. Shrink the rectangle by a zoom factor of 1/3. Make a table showing the area and perimeter of both rectangles. So since I didn't put the graph paper on here, this is just going to be kind of a sketch, but make sure you do yours on graph paper. So when I make the rectangle, I'm just going to label what those sides are. So this side, the longer side, we'll put 15, and the smaller side is 9. And then we're going to shrink the rectangle by a zoom factor of 1/3. So we'll draw another rectangle, a little bit smaller. And since it's by a zoom factor of 1/3, that means the side lengths are 1/3 of what they were. So you can multiply 15 by 1/3 and 9 by 1/3, and that'd give you 5 and 3. And then it wants us to make a table showing the area and perimeter of both rectangles. So first we'll do the perimeter of the first rectangle. 15 plus 9 is 24. Times that by 2, because we got the other two side lengths, means the perimeter for the bigger rectangle would be 48 units. And from doing these problems in previous homework, you might recognize that the perimeter of the second rectangle will be the same zoom factor. So if we went by a zoom factor of 1/3, 1/3 of 48 is 16. Now you obviously could easily check that. 5 plus 3 is 8, times 2 is 16. So it does work out, but that might be something that you remember from previous homework. The area for rectangle 1 first, has an area of 135, 15 times 9, so that's 135 units squared. We want to make sure we label. And then the area for the smaller rectangle, 5 times 3, is 15 units squared. And so I think we've answered all the questions. We've graphed it. We did the second rectangle, and we made a table showing the area and perimeter of both of them.